Hi. This is going to be a story of how and why we are working on Detox at Wix. Detox is an open source mobile end-to-end testing framework. And also we're going to talk a bit about how we use it internally today at Wix. So Wix bet on React Native almost 2.5 years ago when it was in its very early days. And when this tech is so young, we could find a missing brick, wherever we stepped, and especially if we took the technology for more than just a spin. So maintaining quality level of applications is much harder when they grow and evolve, and end-to-end testing was, and still is, a big challenge in mobile, and especially with React Native. So hi, I'm Rotem. I'm a software engineer at Wix. I'm a part of a mobile infrastructure team. And my team does infrastructure work, defining and building development and integration process of the Wix app. We devote a big part of our time for testing methodologies and infrastructure and building better environment for our developers. The unique thing about the work of my team is that most of it is open source. So, flakiness. End-to-end testing is often considered to be flaky in all platforms, in web, iOS, and Android. So what flakiness really is? So flakiness is a test may fail without even getting code changes. Tests are non-deterministics. There are many moving parts in the application. And things may finish executing before other things in different orders, on different runs, or in different environments. And so we can really be sure when application is idle. That's the real cause of flakiness in end-to-end. So users in end-to-end frameworks often have to deal with this synchronization manually. So they just add multiple slips all over just to make the test fast. In fact, we embrace the fact that E2E is flaky, and we created patches, sleep and retry, and sleep and retry. And it's kind of like putting multiple Band-Aids over a strainer. So this is what we actually did on the previous test framework that we used. So you can see here that for a second, we tried to test 20 times if something exists, and if not, we just sleep for 50 milliseconds. So that was the best way that we could have approached flakiness at that time. So how unreliable a test suite really is. Let's calculate the probability of a test suite to fail. So Q is the probability of a failed test, and N is the number of tests. So 1 minus Q, going back. So 1 minus Q is the probability of a single test to succeed, and 1 minus Q to the nth power is the probability of the entire suite to succeed. 1 minus all that is the probability of at least one test to fail. So if the tests are flaky 0.5% of times, and we have 20 tests, then we have about 10% of failing test suites. Hello? Who is it? I'm just kidding. It's fine. Anyway, so if we have 50 tests, and we have around 22% of flaky suites. And if we have 100 tests, well, you get the idea. It's really unreliable. So we used Appium for 2 years in general and 8 months with React Native. And we found that we invested a lot of time just vetting the system and making things like work and getting CI green. And we found that end-to-end test is really, really hard because tests were flaky and we had different results in different machines, frequent failures in CI, and the solution was just adding those dreaded slips all over. Which of course slowed down the tests. And benefits of tests must outweigh the costs. And frameworks which are complicated and fragile can occupy a big chunk of our time. So this isn't actually Appium's fault. Selenium, Calabash, and all others, they have the same characteristics. They all do black box testing. So black box testing is a method of testing stuff from the outside without knowing what's going on internally. In mobile, black box C2E essentially just goes over the view hierarchy, looks for an element. If it's not found, it slips, then continues looping until an arbitrary timeout, and that the framework chooses for us or that we choose. And if the framework found, it interacts with the view. If not, then it just throws an error. Same principles are applied for web black box end-to-end. So what's the proper timeout parameter? Who here thinks it's a second? No one, good. Who here thinks it's 2 seconds? 10 seconds? Do you have 10 seconds? OK, I don't. So actually, everyone is wrong and everyone's right. This is just so unfair to ask users to provide timeout parameter. They have no idea what's going on inside the operating system and what's going on inside the application because they just test it from the outside, from outside of the process. They have no idea what's going on inside. And that's the actual main cause of flakiness. So with Detox, we took a different approach. Detox does gray box testing, not black box testing, to allow the test framework to monitor what's going on inside the application and synchronize with the internals. Gray box essentially is just a piece of code that is planted inside the app that runs in the same process. So it has access to memory. It can monitor the execution of the process. It is able to read internal memory, of course, and this gives us the ability to detect what's going on inside the app. If we have network requests in flight, if animations have ended, we can check what's going on the main thread queue and on other threads queue, what's going on the JavaScript thread, of course. And we can even execute it on the main thread to make sure that when we perform an action, nothing changes on the UI. So this is like an atomic action. So the leading native gray box, I'm hearing myself better now. Something changed? No, everything's good, right? OK. So the leading native gray box drivers are developed by Google, Earl Grey for iOS, and Espresso for Android. These frameworks can synchronize with the application and make sure we only interact with it when it's idle. The underlying synchronization mechanism used by these gray box frameworks works the following way. So instead of retrying an action or assertion on the UI, they will query internal resources every few milliseconds and listen to callbacks from them, telling us when those resources have switched to idle mode or are they still working. So only then, when the application is idle, when all of them are idle, we can interact with the UI. Detox does not rely on Webdriver because this is not the web. This is mobile. Detox communicates with its native driver, which extends Earl Grey and Espresso, using a JSON-based reflection mechanism that we wrote. This allows a common JavaScript implementation to invoke native methods directly. So this is how a simple Detox test looks. We don't need to synchronize or add any slips to wait for stuff to finish. Detox is inherently synchronized. So it will execute a command only when the app is idle. So this will actually wait on this promise. Yeah, this. So, and it's cross-platform. The test code is unaware of the platform it tests. Of course, you can have conditional tests for each platform, but the main API is just doesn't know which platform it runs on. It is test runner independent. So this example is with Mocha, but we actually now use Jest for our own tests inside Wix. It is debuggable because we use async await native constructs instead of just pushing everything into a promise queue. So this means the breakpoints will just work as expected. Traditionally, test frameworks evaluate expectations in the test script running on your computer. Detox evaluates the expectations natively, directly on the tested app. They're actually being run inside the process of the application itself. This enables operations that were impossible before due to different scope or performance reasons. So this is an example of how we translate a simple API call to and what is being passed actually to the device. So await element by text action. This is Actually, that's the invocation JSON that is being sent from Node to the device itself. So what you can see here is that it's a bit small. Anyway, so Detox Metro for text, this is a native iOS function that is being invoked inside the device. And then what we do is this protocol allows us to run multiple native functions and feed each function return value to another function. So we have the complete freedom to build whatever we want and invoke whatever we want on the device. So this is a high-level diagram with a few examples. Let's see a few examples and try to understand how Detox works. So the test runner, this is either Mocha or Jest or whatever you want to use. This runs the action or expectation and then awaits on a promise. On the tester is the Detox node side, the things the API that you actually use that is exposed to the user. The expectation is being serialized to that nested invocation JSON that we saw before. And then on the server, which is just a WebSocket relay that the test runner and the device itself are connected to, it just relays the message through to the testee, which is the device itself. On the testee, the action or expectation are being invoked through method reflection. And then the invocation will only be executed when the app itself is idle. So the invoked result, whenever it's being invoked, is being sent through the WebSocket. And then the tester just either resolves or rejects this promise. OK, so after I tired you with technical stuff, let's see the end result. So this is Detox's own E2E test suite on Android. This is the emulator running the app on the right, the test app on the right, the console running the test on the left. Mocha, we use Mocha here as our test suite runner, but you can use wherever you want. So every line in the console is a new isolated test scenario, so it's actually a new test that we can later take on and shard it and run it on multiple devices. And yeah, I guess it's pretty fast. OK, so during this year, we've been using Detox to automate and improve our release process. We've used we had multiple testing scenarios, and in an iterative process, as we went along, we fixed issues in Detox and came with a few understandings of what makes sense of testing with Detox and React Native and what's not. So in general, there are two types of tests that my team uses Detox for. The first is production E2E, and the other is mock E2E or UI automation. So the main characteristics of production E2E is that it involves every part of the system. It's the closest thing to a real user driving the app. It has many uncontrollable variables, and each can affect the test outcome. If the network is down, the test will fail. If the server has issue, the test will fail. If tests get a different A/B test variant on each run, the test will fail. So the pros of production E2E is that they're much closer. They're as close as possible as we can to a real user experience. Logging with real users against production endpoints. They're very easy to set up. They're very easy to write. You just find an element, interact, and expect. So just use the default API of Detox. There is nothing else you need to add inside. And they can provide very high confidence if they were not so flaky and slow. So the main benefit of them is that they can help the QA engineers replace manual testing methods. But again, they will never be as rock solid as other tests, as unit tests, let's say. Therefore, they're very hard to maintain. So mocked E2E, on the other hand, tries to eliminate all those by setting a controlled and predictable environment. So replacing all endpoints with mock server or data, server and client communication then can be tested with different test suites, with contract tests. OK. So the pros of mock E2E is that these are much closer to actual code, and they're much more stable because using mocked endpoints, we have now controlled and predictable environments such that provides the same input on every test. They're very easy to maintain because once we write them, they should just work, unless we, of course, break things. The cons is that they require much more setup. We now have to write code, server code, and control everything that is that feeds the app itself. And since we have to take care of mocking and all the mock data, so there are a few mocking mechanisms for mocking E2E on E2E tests. Detox has a few useful mocking mechanisms as well. I'll focus on React Native, but this can be done. What I'm talking about is you can do it either with Gradle build flavors for Android if you write native Android, or configurations with iOS if you write native iOS. Okay, so in order for the app to use mock server, we'll need to make sure that the app knows it should not connect to a real server, and it should connect to a mock endpoint instead. So our way of doing it is by creating a new flavor for our JS bundle, one which uses a different endpoint than the production app. So this is already supported by Metro Bundler, and by creating anyfile.e2e.js, we can override anyfile.js and create a custom JS bundle. So with very little modification, React Native can do it, can also support it by itself. And actually, this is being supported natively in React Native 55 and up, so it's already out for 5 months, I think. But on previous versions, if you use previous versions of React Native, you can add React Native repackager to your dev dependencies. And by adding that and running the setup script, it will actually fiddle with your React Native code on your post install and just add the support. It's a very small diff. So let's see how it works. So so we'll create an endpoint.e2e.js alongside endpoint.js, and adding rncli config to the root settings, get sources extensions, will prioritize any given source extension over the default one. So by triggering these commands, these commands at the bottom, the bundler will just use e2e.js and will just override every time we have an e2e.js, we'll just override the JS file and bundle this one instead. So we just get kind of this. So this is an actual test from our mocked E2E test suite. Mock server is an object that lives inside the test runner's node process. It can be altered during test using simple function calls, which makes things much simpler. And once we set up with mock data, the test can just launch the app. So now we can run mock test that verifies that the application can persist login information and does not show login window in subsequent launches once we have a user logged in. Another method that is worth mentioning is testing application output by gathering requests from the application, running the expectations on a mock server instead on the device. So in this case, we have a simple notification server that records registry and unsubscribe requests from the device. And by triggering the application to send these requests, we can make sure that they're being sent correctly. So we'll launch a freshly new installed app, logging in and checking that the server doesn't still have a device token from the device. And then clicking allow in the app, which should send the token to the server using that registry request. And then we can just validate that the server now has a token from the previous sent registry request. There are a few more mocking mechanisms built in Detox. So this was not related to Detox. This was actually just React Native and Metro. But Detox itself has a few built-in mocking mechanisms, which we use all of them inside our application. So we can actually send launch args to the device and then act accordingly. We can manipulate user notifications, either if there are local notifications or push notifications. We can also handle lip links and runtime permissions. So this allows the test to be predictable, to have predictable inputs and produce stable outputs. So we now have pretty consistent results. But I want to emphasize this again. Don't act according to app state, control it. This is so important, I wish I didn't have to say this. We do this when we unit test, so what's different when we do end-to-end tests? In fact, wait a second, okay. Okay, now it's much better. So we kind of learned this the hard way, though. If you have conditional tests in your end-to-end, or even in your unit tests, anywhere, if you have conditional tests, just mock the state and separate it into 2 or more tests. The one rule that guides us in every test scenario is predictability. So predictable inputs should manifest predictable outputs. And I think that now that we made it clear, let's move on to the future. So Detox helps us write better features with more confidence that these features actually work and that we didn't break any of the older features. But there is still a long way ahead of us. And we move in kind of 2 parallel tracks. So the first is internally at Wix while building products. And that is something that this is my suggestion. It's kind of my suggestion to you, but of course everyone has their own setup. So we incorporate both E2E methods in our development and release process. Or at least that's where we're aiming. We set our goal at continuous deployment. And we're working hard to lower our reliance on manual QA. So a few months ago, we started our approximately 0 manual QA process. And this is what we're trying to practice now. So the developers, they write unit tests, they write mock T2E, and contract tests as part of the product developments. This is incorporated in CI, in their own projects. And on every build and on every commit, we run, all the test suites run. And it shouldn't take a long time. It takes about between 5 and 20 minutes to run in CI. And this generates a very short feedback loop to the developer. The QA engineers are, they use Detox to automate their regression and progression suites. These tests will never be as rock solid as mock D2E. So hence they will be decoupled from the build itself, from the actual lifecycle of the build itself. So they have it run on a separate build, and it's just a tool for them to just save time. And scenarios, of course, are owned by the QA team. Another thing about the QA team is that whenever a test fails, so they shouldn't have a lot of failing tests, but whenever a test fails, they can either run it again or just verify manually that things work. But it still saves them a lot of time. Development and QA, they're obligated to synchronize. So QA wanted to educate dev on how to write high-quality scenarios and review mock T2E tests. And by having a good grasp of what's already covered and using the mock T2E tests, QA can reduce the amount of production T2E to the bare minimum. OK, so we've had a few recent features to Detox. The first one is parallelization. We can now run on a few devices, and you're going to see it in a moment. And also, we can now record screenshots, videos, and logs. So this is the Detox test suite running on 3 simulators instead of 1. This is done using Jest. We found out that specifically on my MacBook, it's a 2015 MacBook, running 3 simulators works the best. So from 1 simulator that runs 520 seconds, we were able to reduce it by 215%. I mean, it's 215% faster, to 243 seconds on 3 devices. On 4 devices, if you ask, it's 365 because the CPU just screams, "Help me, help me." I just can't bear it. So the other feature is as I said, recording of artifacts. So what we find here is, I think that this is super helpful, especially when running in CI machines. So we record screenshots at the beginning, at the end, a video from beginning to end of each test, and a log filtered for this specific process. I have to say that this is a bit limited on virtualized machines. So if you run on VMware, like Travis runs VMware on their Mac machines, you may not have hardware support to record videos. And I hope this will be solved soon. I don't really know. But Mac OS Mojave now requires you to have this hardware support anyway. So someone will need to solve it, probably VMware. So now I want to sidetrack here for a bit. For those of you who don't know Detox Instruments, you probably should. It's our performance analysis tool, currently for iOS only. It can be used to gain great insights of what's going on actually inside your iOS app. It's in active development for the past year, and it's already out. It consists of two parts. The first part is a desktop app for data visualization and interaction, and an iOS framework compiled into the app for monitoring. So apart from the usual CPU, memory, FPS, monitoring Apple tools provide, this tool can monitor React Native internal stuff as well. So it actually runs in the same process like Detox does. So we can monitor bridge activity and what's going on inside the JavaScript thread and even network traffic. We believe that this will make a huge impact in our app development and bug tracking. And actually, we're in the process of integrating it into our own development flavor of the app. So every app coming out of CI will automatically have the ability to connect to the desktop application for live monitoring. So our current future plans, and they always change, are writing better error logging. We know this is an issue, and we really are trying to address it now. So there's someone actually actively developing an improved version of our logging as we speak. I mean, not now. It's probably sleeping now. Yeah. We also want to have hook points inside React Native itself, and we're already speaking with the React Native team on just to make sure that Detox will not break on every new React Native version, because Detox actually has intimate knowledge of the implementation of React Native, and that's why it breaks a lot. And we also believe that collaboration between Detox and Detox Instruments will give us the ability to run performance probing on the app during the E2E testing process. So we will be able to save and compare performance counters, statistics between current runs and previous runs, and raise alarms or fail builds upon performance degraded runs. And I believe this could be an industry changer. Yeah, so I'm kind of done. So thank you very much. I'm writing about Detox and other React Native related stuff on my Medium, though I don't really, but I really should do it more. So anyway, follow, clap, or don't, though I do mind. Thanks very much.